So when I started inheritance, I used the word is a. And, they go together. And we're going to look at this is a relationship a little bit more in depth. And when I about inheritance, people were getting confused and think, there's extends, there's implements. I know they're different. And I told you, extends reduces your work. Implements adds to your work. So in that sense, they're different. But in many ways, they're similar. Okay, so what we'll do right now is try to unite these two relationships into one relationship, the is a relationship. Okay? And study this relationship in depth. And that's what's really going to help us write. I mean, we still don't know quite how to write OO programs. Okay? And if we don't understand this relationship well, we can write all our classes, but we can't use them quite. Okay? So let's talk of is a. We gave examples. We said human is a mammal, salmon is a fish, a Cartesian point is a point. So if I was to tell you, define in English what is a means, what does A is a B mean, really? It's a subclass or subtype. That's you're talking Java. You have to go. Sorry. Oh, you're using subclass and subclass as a generic term in English also. That happens a lot. So what's your name? Austin? Austin?
So human is part of the group of networks.
Yeah. So that's good. It's a part of a group, and that's what he was saying. A subclass or subset. But I want a generic definition that A is a B if, James, you're going to say something? If A is an element of the set B. Okay, but the question becomes, how do you group things into sets? Yeah.
A is a B if A has various properties and characteristics that characterize
B. Okay. Anybody want to improve that? A is a B if A has all the properties and characteristics of B. Yeah, James?
A is if there's a set of properties that all B's have and B has them, A is a B.
Okay, so if B has certain properties, A also has them, and A can have additional properties too. Okay?
If A is a B, then you use A wherever B is.
That's excellent. If A is a B, then wherever B can be used, A can be used. Excellent. That's the basic point of this whole slide deck. Okay? And T1 is a T2 if T1 has all the traits, and in the case of Java, all the methods and variables of T2. That's is a. Okay? Whatever trait quite means. Okay? So by that definition, a string history is an object. Right? A string database is a string history. Is a string history the class? Is the class a string history the interface? Can I say the class has the traits of all of the interfaces it implements? Yes, you had to go and implement it, but once you implemented it, you've got the traits. You had to do more work, fine. But after the work, that particular type defines you also. Wherever string history can be used, a string history can be used. That's a nice rule to have. So basically, if I was to define it very carefully, I would say if T1 a type implements T2 a type, then T1 is a T2, right? So a string history is a string history, okay? The interface. The class is a interface it implements, okay? And a string database is a string database. Okay? If T1 extends T2, then we can say T1 is a T2. So string database is a string history. A string database is a string history. Okay? I mean, I'm just saying what you guys intuitively got it in like 5 seconds or 1 second. Okay? But we're just formalizing it because this, we have to define a lot of things. And we can say transitive, right? That if T1 is a T2 and T2 is a T3, then T1 is a T3. That is why everything is an object. Okay? So a string database is a string history because a string database is a string history, which is a string history, the interface. Okay? And again, this sounds more complicated than it is, because I think you guys got it. Marco?
Just to make sure, in all these examples, every time you're comparing, every time you're doing you're checking for interfaces.
I'm checking for traits. It's not interfaces always. Just look at this. This happens to be an interface. This happens to be a class. This happens to be a class, and this happens to be a class. This happens to be two interfaces. So both interfaces and classes are types. And I can ask the question, is any type is a type T2? Is any type T1 is a type T2? And those types can be classes or interfaces. Okay? Questions? Okay. How about this? Is it correct to say string history is a string history? Every class has its own traits, right? So we'll say yes. Okay? So that's our formal definition, using some symbols. And again, you guys intuitively got this, but this is just a formal way of explaining this. Okay? We understand is a. Why is it interesting? Why do we, we spend all this time, we define, we have great definitions. Why bother? I mean, we want to program our project, right? So who cares? Or why should you care?
That's a good question.
I think that then we can create relationships that will allow us to write less code. And if we need to alter it and correct it, we only have to do it once rather than remembering where all we have that code and doing it multiple.
Okay, so if we are implementers, if we are programmers, and we want to reuse code rather than write code from scratch, we better understand all the is-there relationships there are so that we can write our own code. If we are maintaining the code and we want to go and understand why it works the way it works, we better understand all these relationships so that we can maintain the code. And that is why we do this here, right? Why do we organize our species into these is-there relationships? If we are studying primates, let's go and study mammals and use our study to go and figure out how primates behave. And we are maintaining. If you're a doctor, you're maintaining, right? You're trying to fix people. So you want to know how the genes got inherited, and you want all these relationships, and you don't want to have to go and relearn each type, what it is. You want to, ideally, if these relationships hold true cleanly as they do in computer science, you want to do it. Okay? So it's good from the point of view of an implementer. We want to know how our code is organized, and if we are grading you, we want to see, what it is. So for maintenance, building things. How about users of the type? If I'm going to use these types, I'm not going to implement it, I'm just going to use these classes to build other classes. Do I need to know the relationship among the used classes and type interfaces? If I don't know the relationship, I can't quite use them properly. So when I use a class, I have to worry about type checking. And type checking rules depend very much on the is-there relationships. And let's just do an example. So there was a world which was very simple at one time, where we had only classes and no interfaces. Okay? And in that world, typing was easy. We used a class to type. We then went and gave a value that was exactly the type of. So when we had a formal parameter, our formal parameter was declared to be of type class, or if we had any expression, it was a class. And when we had a value that we were passing, an actual parameter we were passing to the formal parameter, our rules were so simple. The class of the formal parameter should be exactly the same as the class of the actual parameter. Life was very simple, right? And, we avoided simplicity for complexity. We replaced it with complexity because we said, what if I have another BMI spreadsheet and then I have to go and define two methods that do the same thing, except that one takes a BMI spreadsheet, another takes another BMI spreadsheet, and to one I can pass another BMI spreadsheet, and the first one I can pass a BMI spreadsheet. So the fact that both of these classes implemented the same interface was not being exploited in our code, and we as users were duplicating code just because the rule was the expression that is being assigned to a variable must have the exact same type as the variable. So this exact typing was easy to understand, but got in our way. Okay? So we wanted to things, and we said, you know what, we'll use interfaces. And then I made a rule, you will not go and type any formal parameter with anything but an interface. And this rule was meant to avoid problems of the kind we saw earlier. Because now if I go and say BMI spreadsheet, the interface, I can pass it a BMI spreadsheet, and I can pass it another BMI spreadsheet, and they're both legal because another BMI spreadsheet is a BMI spreadsheet. A BMI spreadsheet is a BMI spreadsheet. It was the is there relationship that was being used, and that is why this polymorphism worked, where you have this method that takes values of different types, and it still works. So that's why it's polymorphic, rather than overloaded, where we had two methods with the same header, with the same name. And so a BMI spreadsheet implements BMI spreadsheet, another BMI spreadsheet implements BMI spreadsheet. So that is why we could do this. And the more general answer is that because the expression class, the expression type was the variable type, the actual type was a formal type, that is why it worked. Okay? So our type checking rules depend very much on is-a. That is what is being used. And if we don't understand is-a, we can't really use the types. Yeah.
Which class is the method?
Which class is this class? Which class is the method print in? Some user of that class. Some UI class, my main class perhaps, in which case it would be static. But it is in some class that is not one of these classes. Okay, that is fine, right? You guys have done this. You have a main class that uses the scanner and the token. So if it was in the main class, I would have to make it static. But it could be something that is just a UI class that displays things and doesn't do anything else. Okay? Okay, we'll carry on from here next. Okay, questions? Okay, so we were doing inheritance, and we saw that inheritance and implementation, okay, are both related, and the relating concept is is-a. Okay? And is-a is something we see in ordinary life, and we got several definitions of is-a in class. The one I gave you and the one many of you gave yourself is that some concept, T1 is a T2, some kind of typing, whether it's in programming languages or in ordinary life. T1 is a T2 if T1 has all the traits of T2. Okay, and in our case, the types are programming language types. So the traits we're looking for are methods and variables. Okay, and then there was another definition which is going to come in handy today, which was that T1 is a T2 if the set of members of T1, okay, so this types, basically by typing you are putting some label on a set of things, members, and they all become part of that set. Okay, so a type defines a set. So T1 is a T2 if the set of members of T1 is a subset of the set of members of T2. Okay, so T1 is a special case of T2. That's another way to read is-a. Right? And then the third definition we got, which is the one I really liked actually, and the one we're going to use today also in certain contexts, is that if you can substitute the general type with the specialized type, then that type is a specialized type. So T1 is a T2 if T2 can be substituted by T1. Okay, so wherever type T2 is required, we can put type T1 in. And what does that mean? That means whenever some member of T2 is required, we can give in a member of T1. Okay? So if you are required to go and have a professor who can teach 401 in this class, and if you get somebody who can teach both 401 and some other course, that's okay. They can teach 401. Right? And we saw that in Java, the is-a relationship is defined by two different relationships. Implements defines is-a. So if a class implements an interface, then that class, that type, is that interface. Okay? It has all the properties, it has all the methods of that interface. So by all the definitions we've seen, that's true. And if an interface extends another interface, or if a class extends another class, then the specialized type is the general type. Okay? Again, when you inherit, you get all the features of the what you inherit from. So again, our definition, the general definition is holding true, and these two relationships now do unite, as I said. Okay? And then we said, why is that interesting? Yeah. Ashley.
It implements and extends about both types of inheritance?
So extends means inheritance.
Okay, but implements doesn't.
Yeah, implements means obligation.
Obligation, okay.
Remember? So inheritance means you get the money, and obligation means you have to have the money. Okay? So so you somehow have to implement that. So is A is the one that they're both special cases of. Okay? So when you said are they both forms of inheritance? No, they're both forms of is A. Okay? And why is A important? And in ordinary life, we tend to classify things. And when we classify things, we understand things better. And especially if you're a scientist trying to understand mammals, okay, then, and you're doing something that works for all mammals, then maybe it'll also work for primates, right? Because primates are mammals. So we can, when we want to target certain classes, we can look at the hierarchy of classes to see what we've actually been able to accommodate. Okay, and in programming languages, again, if you're designing a new kind of collection, it's good to know that there's a string database that inherits from string history, that inherits from object. So you can, from that hierarchy, go and put your own type somewhere in that hierarchy, so that you reuse what you want to reuse and not anymore. Okay, so from the point of view of programmer, it helps in understanding the designs and implementations. And it also helps the users of the type. Okay? So here, the substitution rule comes in handy. That you're not going to define the types that are involved in the hierarchy, but you're going to use them. And maybe you can substitute one type with another type in your reuse. Okay? In your use. So, and the example we gave was the sprint method. The sprint method is dealing with BMI spreadsheets. It's not itself in the BMI spreadsheet class. It's something we're defining separately. Okay? And we could have defined a print method for a BMI spreadsheet and another print method for another BMI spreadsheet, and they'd be doing the same things. And we'd rather go and define a print method that says, give me any BMI spreadsheet, anything that has the characteristics of BMI spreadsheet. And then you can pass to it another BMI spreadsheet or a BMI spreadsheet, and the same method works. And this is what we said was polymorphism, rather than overloading. Okay, in overloading, you have the same method header, but you have two different implementations. Here you have one method header and one implementation. Okay? And what we essentially were doing was assigning to this formal parameter this actual parameter. So you were assigning this value to this particular variable. Okay? So the rules then the issue then we have to address is, what are the exact assignment rules? Okay, and we are seeing that here, that we can assign some type T1 that is a type T2 if the formal parameters of type T2 and the actual parameters type T1. Okay, and let's just go and see this now with more examples. So that's the basic. So what we're going to cover today is mostly these type checking rules, and they can get complicated. They're not as simple as they might appear at this point. Okay. So I put in a bunch of statements here, which are assignment statements, and tell me which are going to pass the Java compiler and which are not. So can I, and I'm typing here using class, which we shouldn't be doing in this course, but that's legal in Java. So let's try to understand Java in general. So we've got string history declared to be of type the class string history, a string history, and I assign to it a string history. Okay? So I'm using exact typing. Surely nobody can complain here. Okay, so this is going to pass. I am assigning to a variable typed using an interface a value of some class. A string history implements string history. Okay? We've seen this before. Nobody's going to complain. You've done this in your assignments a lot. Okay? Now things get a little more interesting. I've declared the variable to be of type string history. The interface, I've assigned to it a string database. Okay, and this is going to be allowed? No? So a string database, does it implement the interface string history? A string database is an extension of a string history which implements the string history interface. A string database is a string history. This is what we have. This is what we are expecting. This is what we are substituted with. We can always substitute with a more specialized case. That's what our rules were saying. Right? Questions? Okay, what about this? I've declared something to be of type string database. I've assigned to it a string history. No. I'm expecting a specialized case. I'm getting a more general. I'm expecting a 401 professor. I just get a professor. Okay? Okay, so, that's English, that just makes intuitive sense. What can concretely go wrong if I do this, by the way? If Java said, fine, who cares? Yeah?
There might be a method in string database that the string history doesn't use correctly or doesn't.
There might be a method in string database that string history doesn't have. And when compiler does its compile checking, it says, okay, here's a variable, and let's just go look at that. Okay? So, by these rules, this is not applying, and let's go and justify these rules now. Okay? And when you go and declare something to be a certain type, you're telling Java, this is a promise I make you. I'm making you a promise that I'll assign to that variable some value of that type or its special case. Okay? And please do your type checking on that variable. Okay? So a variable is just a name. Who knows what that name is going to be associated with? But Java is going to type the name and say, at compile time, I will do some checking. And by the way, this is what Java does. It's not that every language does that. Okay, Smalltalk did not require you to type variables like this way. And it said, we'll just let you do whatever you feel like. And depending on what objects you assign to variables, we'll give you at execution time some error. Okay? And Python has taken that philosophy. And as a result, if you want to program quickly and if you're a careful programmer, you like Python better because you don't have to go and type things and then have somebody check your work. Okay? But here we are telling Java, I'm declaring this to be of type string database, so please use this variable, please do the appropriate checks on this variable, and I promise to you that I will assign to the variable appropriate value, and if I break that promise, you check me. You can check me. You can do the checking also. Okay? So Java says that if you declare something to be of type string database, you can say string database.clear because clear is a method in string database, the interface. Okay? So you should be able to say string database.clear no matter what object is assigned to string database. Which means you better not be able to go and assign to it an object that does not have a clear method. Which means you better not assign to it something that's more general than what is expected. Okay? Yeah.
I thought you just said it would work.
This is, you tell me, how can it work? Clear is something you cannot do in a string history. Right? History is something you don't rewrite. History is the more general case. Clear is a method you added to string database when you extended string history. Okay? So when you say something is of type string database, you're saying I can do clear on it, which means I better assign to it a value that is clearable. Okay? And I'm going to have a little analogy later which will make probably things more clear. No pun intended. Okay. Fine. Any other questions? Okay. This type is not this type. The right-hand side type should be the left-hand type. That's a general rule. What you're expecting is on the left-hand side. what you're getting is on the right-hand side. What you get should be a special case of what you're expecting. Okay? Questions? Okay. Now let's look at this example. I declare something to be of type string history. I got lucky. I got a more special case, something more sophisticated version of what I really was going to be happy with. Okay? And I can say string history.size because size is a method in string history. Okay? It's also a method in string database because it is a special case of string history. String history.clear, should you be able to say this? Even though I have been assigned to string history a string database, I should not be able to say this because?
I was just going to say, the dot clear method, is that in the string database?
Yes, it's in the interface string database. So I declared this variable to be a string, so clear is in string database. This variable is declared to be of type string history. Clear is not in string history. I should not be able to call clear for that reason, right? But I got assigned a string database. You got somebody who can teach 401 and compilers. Does that mean you can't ask them compiler questions? That's what this is saying. Right? So, but when the programming language when the compiler does its checking, it doesn't know what you got. So we can't design the course assuming that a compiler professor will teach you. Okay? So this is going to be illegal for exactly that reason, because you don't know what you're going to get in this variable, and you have to make the assumptions in the type. Otherwise, things will get messy. What do you think this is saying? You guys are, yeah.
Still in Java to recognize string history as a string database, so it can call string database methods. It
is saying recognize. That's very good way to put it. It's saying, I know I've been declared to be of type string history. I know you're going to scream at me if I do clear, but don't scream at me. I'm going to get lucky, and I expect to have a string database assigned to me, and that is legal. I can be assigned. We see that here. So assume that I got assigned a string database, actually. Even though I've been declared to be of type string history, just assume here when you're doing a compile time checking that I got declared as a string database, and do your checking assuming I'm a string database. Because I might be. And if I'm lying, we'll figure that out at execution time. At runtime, it's going to try to find a clear method in the object. If it doesn't find a clear method, it says, oh, you lied, I'm going to give you, and how's it going to tell us that we lied? At runtime, what kind of errors do we get? It's going to get some kind of exception. Class cast exception. Right? So you say, I'll deal with the exceptions. Okay, I know I'm working with Java. I know I'm supposed to get all my errors cleared up at compile time. But, just to get more flexibility, let me be a little adventurous here, and I'll deal with the exceptions. And so just type this as string database, and then let me call the methods. Okay? So that's what you're doing.
So the string history.clear doesn't work, but the one below it would, string database string history.clear.
It's not a question of working, it's a question of what the compiler will accept. Okay?
So the one under is like more direct.
So which do you think is going to be accepted by the compiler, this or this? Okay? So this will not be accepted. It's saying, you're making no promises, you just made a mistake. And you don't know the rules. Here you're saying, I know the rules. Okay? Just trust me. And if the trust fails, give me an error at runtime, which is what happened in Smalltalk, which is what happens in Python. So it's saying, okay, what Java says is that if you really want to live adventurously, do some extra work. And tell me that you know what's happening. Okay? And don't just expect things to happen this way. So it's trying to accommodate both the advanced programmer and the safe programmer. And I shouldn't say advanced, I should say the adventurous programmer and not so adventurous programmer. Okay?
So what benefit do we have by declaring string history
Okay. So if we are really so sure that this is going to be a string database, why didn't we declare this to be a string database? The thing is, we are not sure. We might get one or the other, and we are saying, if I get this, let me just do this extra thing. Okay? So it's casting is a very ugly thing. And you don't want to use it very often. But sometimes you're forced to. Okay?
When you cast string history as a string database, do you have to cast it every time you want to call the clear method?
You have to cast it every time you call this clear method. You're saying, when it reaches this execution, this statement, I expect this to happen. When it reaches here, I still expect it to happen, because between these two statements, I could have reassigned string database, the variable. So you're saying, at this point, I know it's this. Maybe at later point, I will have a more general case. Okay? Okay? And can you guys see this in real life? I kind of gave you the 401 example that, you're expecting a 401 instructor, you got a 401 and a compiler instructor. Other examples you can see in real life where these kind of is-a rules work with cars, with animals. So if you need to be assigned a vehicle, or if you are being promised a pet, right? You could get a car. You could get a car or a bicycle, and you can't complain. Okay, you want to come to the university. You need a vehicle. You get a bicycle. That's what you get. I mean, that's fine. Okay. You get a cat or a dog. You can't complain. Okay. You expected the general case. You got a specialized case. You won't be unhappy. All the things you were going to do with the vehicle, like go from one place to the other, you can still do. Okay? If you need to be assigned a car, okay, or a dog, then a bicycle or a cat will not do. Right? So one is not a special case of the other in the second set of examples. Okay? And just to drive the point even more home, so you requested a regular model. You're not going to pay too much money. And they're out of regular models. But what they can do is assign to you a deluxe model with GPS. Okay? And if you're making your plans, you're writing down your plans, and you're going to get your plans approved by somebody like your parent, you can say, okay, I've ordered a regular model. And you can then give your whole travel plan based on the regular model. And the rental car is within its right to assign to you a deluxe model. You can't complain. A deluxe model is a regular model. Okay? So, you can steer both cars. And as far as, when you make your plans, you tell your parents, okay, I'm not carrying my phone. I'm just going to use a GPS in my car. And they're going to say, you just ordered a regular model. It doesn't have a GPS. So you can't do this. That's your compiler saying, no, you can't do this. Okay? So you have to take your phone along. Okay? But you can say, look, okay, I'll take my phone along. I'm going to deal with what is expected. But in case I get a regular model, I'm going to go and use the GPS. That's why you're saying a cast. You have a backup plan, but you're saying just in case I got assigned a deluxe model, I'll go and do this. And that is allowed. Okay? And just the fact that you're casting means you know what you're doing. And so that's sort of the analogy. Okay? And the reverse, deluxe model, so you ordered a deluxe model, you didn't carry your phone, and you were going to go and use the GPS to go and set the city, and suddenly if you were actually assigned a regular model, that's not going to work. And you don't have your phone with you. Okay? So this is a bad situation. And that is why when you go to the car rental company, that assignment is just not going to work because you were expecting something else, you made your plans based on that, and you can't be given something that doesn't have all the features that you expected. Okay? You can be given something with more features, but not fewer. Okay?
my car is already the Lux model and typecasted as the Lux model,
Yeah, if you're already a type and you say, I'm typecasting, Java says fine, you like to type, so go ahead and do this extra typing. You'll never get a runtime error. Actually, it'll become a little inefficient. Sorry?
it doesn't change it at all. It's already that type that you're typecasting into.
Yeah, so if the variable was declared to be of type deluxe model, and you assign to that a deluxe model, and then you go and cast deluxe model to deluxe model, you're just doing some extra typing. But it's legal. Okay? Questions? Okay. And these ISA rules are going to come in various places. So let's just get some more practice with them. So I declared something to be of type object, which means I'm just a vanilla object. Okay? And I've declared an array so what I've declared here is the variable objects, which is an array of type object. Okay? Should I be able to assign to it this string constant, where the first element is a string, the second element is a database, the third element is a string history? I've declared this to be of type is an object array, so should I be able to do this?
Yes.
Every element here is an object. Okay? Even though when you think of arrays, you think of arrays as being homogeneous elements, you guys know actually from your assignment that you can assign to an array of the general token type a specialized token. So this is not news to you at all, actually. Okay? What about here? I'm expecting an array of strings and I've assigned to it a string and a vanilla object. You can do this. You can just say, give me a vanilla object. Okay? Not legal, because every element should be a string or better. Okay? So the elements of an array can be of different types, and again, you've seen this concept before. Okay. Now let's try to put these things together. So I gave you the ISA rules, and I said T1 extension defines an ISA relationship, implements defines an ISA relationship, and by transitivity you get ISA's relationships. And of course, if your T1 is equal to T2, then it is an AT. Okay? So that's what we define ISA as, and then we said, okay, now we use ISA in this rule, that value of type T1 can be assigned to a variable of type T2 if T1 is a T2. Okay? So we understand this rule, and we've applied this rule many times. Okay. Is this legal now? I have assigned to string history a string database. That is legal. Then I assign to object O, variable of declared to be of type object, a string history. We know the first assignment works. We just saw that in the previous slides. Should the second assignment work?
Yeah.
Is a string history an object? Is something that is a value of type string history, the interface, an object? Intuitively, it is, but tell me which rule tells me, through which rule do you derive that relationship? For this rule, it's very clear. A string database implements string database, the interface, which is an extension of string history. So from the class, you went to an interface, and then from that interface, you went to its super interface. Okay? I can give you a path along that tree. Tell me some rule. Tell me what path you use to say that a value of type string history, the interface, is an object. One is a class. This is an interface. This is a class. Is there any way to go from an interface to a class? Is there a relationship tying an interface to a class? From a class, you can go to an interface. A class implements an interface. So you can follow the implements arrow from class to interface and go to an interface. Okay? Can you go? Yeah. Austin? So does an interface extend an object class? Can an interface extend a class? A class can extend a class. An interface can extend an interface. An interface cannot implement a class. That obviously is wrong. An interface cannot extend a class. There is no such thing. You can't say interface extends class. Even though intuitively you guys got the right answer, these rules don't give you that answer. Okay? Yeah.
Did you say on the bottom line that lowercase string history is an interface?
This is string history, right? This is
I mean, the one below that. That's not. What is
string history is typed as. This string history is typed as the interface.
so string history, like the bottom one?
That bottom one and this string history are the same variables.
Yeah.
And this variable's type is
String history.
the interface. So on the right-hand side, I have an interface.
Oh, so even though you created it as an object on the first line, it can become an interface.
Well, that's what we see, right? We see that variables are typed as interfaces, and we can assign to that variable anything. Ultimately, it has to be assigned an object. We know that.
So you're signing a string history with the lower s, with the smaller s. You're signing that as a type of the big string history, which is an interface. So then on the right side, when you say object node is equal to string history, then it's being equal to that interface.
Yes, so I'm saying on the right-hand side is something typed as an interface.
Right, yeah.
On the left-hand side is a variable typed as a class.
Okay.
We have seen that the right-hand side must be a left-hand side. Can an interface be a class? And we know that through implements and extends, we define is-a relationships. A class can implement an interface, so a class can be an interface. An interface cannot implement a class, right? An implement cannot extend a class. So our rules are not sufficient to describe what our intuition says. Okay? That's what the point is. And this is the picture I'm showing you here, that this particular assignment is fine. A string history can be assigned to the interface because, because it implements string history. And this one, we can't quite, and what this is saying really is that when I print line string history, I'm calling the toString method of string history, and the toString method is id object. So for the, we want that to happen, and yet that's not happening because of our rules. And because our rules say the interface is not a subtype of class. Okay? So we won't be able to even do this. This is another example of the same rule being applied. And that statement was legal, and this is also legal, but our rules are not saying it's legal. Yeah.
Can you explain that first line again? The lowercase string history is a type of the interface string history, but you can assign any object to it.
Not any object. Any object that is a string history.
That is a string history.
That's what you've been doing. I mean, if you've been typing your tokens using a token interface, you've been assigning to it some class that implements that interface. Right? So you guys have been doing that. So this one is easy, relatively. This is all new stuff for you guys. You need practice with it, and that's what the next two assignments will give you more of. You've already had some practice with interfaces, and that's part of the reason why I insist on interfaces. You really have to understand there's all these benefits of interfaces, plus you also have to understand the is-a rules well. And the quicker you're exposed to the is-a rules, the better. Okay, that's what makes OO programming powerful. That's what makes OO programming confusing. Okay, so the first statement is right. The second statement, you're saying print line string history, and that means that you're calling the toString method an object, which means you expect string history to be an object. Okay, and our rule doesn't allow that to happen. And so basically we have to add another rule. Okay, which is that given any type T, it is an object for all T. So for all T, T is an object. And we know that any variable that's typed using an interface will be assigned finally an object. What will be actually assigned to it will be an object. So we know this is true, that ultimately everything is an object. So we just add this rule, and that rule we have to add mainly because object does not implement an interface. If object implemented an interface, we wouldn't have had this problem. Okay? Sorry, maybe I went too quickly. Any questions on that? So just, there's a special rule, that's all, for object. Okay, and if object implemented an interface, then we would just, object would go to interface, toString will be defined in the object interface, and we'll be able to print line that string history because toString is defined in the interface. Okay? Okay, let's just go to something simpler, the 110 kind of stuff. Okay? And see whether we understand that, because type checking happens there also. If I assign to int I the value 2, no problems. Exact typing, we know how that works. If I assign to double D 2.5, we know that will work. Okay? Exact typing. But we can use flexible typing even with primitive values. You know, all these ISA rules I've given you have been defined for classes. You know, implements is something that is for objects. Implements is something that we define for objects and also extend. Now we get to primitive values. Is the first statement allowed? Can I assign to I 2.5? No. Because a double, not every double is an int. But every int is a double. Conceptually, it may not be stored as such, but conceptually every int is a double. So the second would be allowed. And would this be allowed? So we are saying, trust me. I know I type extra. I know, you know, I'm trying to be, you know, a little extra smart. Okay, and I know my smarts will be fine. And so do this. And what do you think I will get? 2? Or does it round it up? Or does it truncate? Okay? Truncate. And I think that's what it does. But you've got to remember that. And that's what you get. When you say I'm casting, you're saying, look, I know the semantics. I looked it up. And I'm fine with it. Okay? And that's why Java will not by default do this for you, because you may expect it to be rounded or you may expect it to be truncated. And so we don't want this to allow this. So this is a thing that I'm talking about in terms of objects. Also works for primitive values. Same concept. Okay? Same general concept. And the concept is this subset thing that if T1 is narrower than T2, it's a subset of T2. Okay? Then expression of type T1 can be assigned to variable of type T2. Okay, we've seen this before. We're just seeing that in a new form with some new relationships, and that's basically it. Okay, and you can assign, you can break these rules by using casts. Okay, and here's something confusing, and I've seen students get confused about this because they do use their knowledge from primitive values to objects, and here's where the confusion comes from. So when I took that double 2.5, the word double means what? It means that size of that value is double the size of an int value. That means in memory, it's fat value. I took that fat value and converted that to a skinny value. That means there was some conversion in primitive casts. Okay? In object casts, never does a conversion happen. Those of you who've seen vectors and array lists, you might say, why can't I just cast an array list to a vector? And that does make sense. You can convert an array list to a vector because they implement the same interface. Okay, but that's not what Java will do. You better go and explicitly go and take all your array list elements and put them into a vector. Otherwise, that cast is not going to do that. Okay, so a cast among object types will never convert the value. It will only say, please use different rules for type checking than what you would use if I was not to cast. Okay. Questions? Okay. Okay. So we've looked at this as a relationship, and we've seen that it's good for the programmer. When they want to define something new, they can go and look at the hierarchy of things that exist and subtype and reuse things. And it's good for the user of that type because they can then decide what kind of assignments are legal. And let's go and look at the ISA relationship. Now, the ISA relationship is defining, I've got these boxes, I've got these arrows. So whenever I've got a box and arrows, I've got in general a graph. And a special case of the graph is a DAG. And a special case of a DAG is a tree. Okay? And what we have is a tree. You guys remember the difference between a tree? What makes a graph a tree? Yeah.
There's only one path. Child.
So there's only one path to a child. Or a child has only one parent. Okay? And do we have more than one path here? No. So, does it make sense to have a DAG in is there relationships? Can you inherit from two different types? Why not? I mean, conceptually. So in this example, can you show me some, can you convert this into a DAG in a reasonable fashion? I've got an example you may not think of as reasonable later.
With the cars, you can have the Ford inherit from Honda and the car.
But Ford can inherit from a Honda and a car, but Honda inherits from a car, so that's not...
Not really. They do trucks, they do motorcycles.
Okay, that's good, that's good, that's good. So how Honda could be uniting both motorcycles and cars, and you can inherit, yeah.
Yeah, I have another example. So you have like warriors sort of fighting. You could have just like say a regular warrior, and then you could have say a warrior with arrows and a warrior with red horse. So those would be two. Then you might want to have warriors with both red horses and use arrows.
Right, so you can have a warrior who's both a marksman and a warrior. Not every marksman is a warrior, not every warrior is a marksman. Okay, so you can define all these relationships, right? And with the horses and everything. So I try to use my imagination with the examples I had here. Human and vehicle. So, maybe a parent is one that inherits from both. Okay? But a string history, and so in classes, I could have something that is a string history. I could imagine something that is also locatable, right? Something you can put on the screen. And I could have a locatable string history. Right? And so the syntax for doing this is very easy, right? I say a locatable string history extends a string history, comma, a locatable. We've got the syntax, we've got the reason. Do we actually have it in Java? What do you think? Is there any reason to not have it in Java? I mean, we've got all the comparing arguments with warriors and vehicles and classes. Is there any reason to not? Yeah, Austin?
Maybe a string history and a locatable methods called the same name.
Maybe both the classes have methods with the same name. And do you know whether they do have? Given any two classes, can I say they definitely have this method? Well, actually, let me not confuse you too much. Let me just give you the example. ToString. Everybody has a ToString that comes from object, but any class can go and overwrite that. And now I've got a string history that has a method implementation that's different from a locatable implementation. Okay? This guy goes and prints out all the elements in string history. This guy goes and prints out the x and y. And now the question is, this ToString is inherited from objects. So this can happen for any two classes. For any two classes, this ToString method can be overwritten. It doesn't have to be. That's why I kind of backed off from what I was going to say earlier. And which method should I choose in this locatable string history? Okay. So if the purpose of the language is to reduce confusion, then maybe it won't allow multiple inheritance. If the purpose of the language is to give you a lot of flexibility, then maybe it will allow inheritance. And James Gosling had this choice in front of him. There was Smalltalk that did not have multiple inheritance. There was a version with multiple inheritance, but that never became that popular in Xerox, which is the company that invented it. Then there was C++, which said there is multiple inheritance. And I don't know what Gosling was thinking. He either flipped a coin or decided to be safe, and I think he decided to be safe. So he said, sorry, we're not going to allow multiple inheritance among classes. Okay? And so that gets in your way, but maybe it causes... So it's a trade-off. I'm not saying one is better than the other. Okay? And that's why language design is so much fun, because you've got to make these trade-offs. And your users, programmers will either curse you or bless you. And the idea is that we have different languages. You really want multiple inheritance, you go to some other language. But it was decided not to have multiple inheritance. Okay, so I'm bringing this in because right after class last time, people came to me and said, can we do multiple inheritance? And I said, wait till next lecture. And that's the answer. Okay? But, so this is not allowed. Okay, now tell me, that's among classes. Let's see among interfaces. I have string history, the interface. I have locatable, the interface. And I have locatable string history, the interface. Can anything go wrong when locatable string history extends string history and locatable? You'd say no.
Because the methods are just the headers, they have no actual body. So if there's a two string in each one, there's two strings.
Yes, so they're sets of headers. So when you add duplicates to it, it's the same set. And if the headers are different, then they're different methods. There's no confusion. If the header is the same, there is no implementation, so it's the same. Okay? So should Java allow multiple inheritance among interfaces? We can't see an argument for not doing it. And we can go and do all our classifications of warriors and Hondas at the interface level. That's again why I focus so much on interface. You're typing, all the classification and typing rules occur at the interface level. And at the implementation level, sure, you went and duplicated some code, and there's ways to get around that also. And that's called delegation, which we'll get into in depth. And so this is allowed. Okay? And the analogy is that, when one parent has black eyes and the other parent has brown eyes, the question is, which color eyes do you have? And then you have to figure out which is recessive, which is not, which is dominant. And you have to know all these details. And that gets confusing. So, inheritance among classes is like trying to determine which color eye will you have. But interface is saying the mother will also have eyes, the father will also have eyes, so you will have eyes. Okay? There's no confusion there. Which color is the confusion? That's the implementation.
Okay, so we're taking string history and locatable over here. They're just two different types of the same method.
Locatable is one interface. It's an interface.
Yeah.
Remember my convention with something without an adjective is the interface. Something with an adjective is qualifying the interface and saying I am a vanilla specs thing. Okay? So we have two interfaces. They both have, in both interfaces I put the method toString.
So it's located in both.
Sorry?
The method toString
is in both interfaces.
Okay.
And so which of these headers does this particular interface inherit? Well, both, because they're the same. So it's a set. So we're just removing duplicates anyway. I can type the same method multiple times in a single interface, and Java won't complain. It says, well, you like to type extra, it's the same thing. I'm just going to convert that into, I think it will do that, it won't complain. But I'm just going to convert that into a set. Okay? Whereas in the other case, the same headers with different implementations. They are not equal to each other. We have to choose. There's no choice to be made. And that's why, again, logically we should have multiple inheritance, and interfaces works more at the logical level.
What if you have two methods with the same name but that return different types?
Two methods with the same name that return different types. So Java, supposing you have just one class, forget about inheritance. Supposing I have in the same class two methods which have the same parameters, same name, but the two methods have different types, return values. That means I'm trying to overload the method, but my parameter types are same, but the return types are wrong. Anybody knows? Have anybody tried that out? Forget inheritance here. This is outside inheritance. Anybody try to figure out? Yeah. It doesn't let you do anything. It'll say error. Why do you think it does that?
Because the parameter types are the same for both of the two methods, then it doesn't have a way of distinguishing which one you want to call.
It doesn't have a way of distinguishing. Well, it could use a return type, but the trouble is that there's too many variables. Firstly, when it goes and evaluates right-hand side, it's not even seen the left-hand side. And it's got to go and figure out the left-hand side context and the right-hand side context, and these variables can't be solved at compile time. So you just cannot have that, regardless of inheritance.
Okay. So if you try to put that into different interfaces and have an interface extend those two interfaces,
it won't let you do it. So supposing this guy returns a mutable string, if there was such a string, okay, it won't let you. It won't. As long as those two interfaces are not related by an is-a relationship. Okay, if they're related by an is-a relationship, then the rules change. Okay, then it'll, as long as one is subclass of the other, it'll allow. One subtype of the other, it'll allow. Okay. Questions?
Can you repeat that again? You can't have two methods that are like the same parameters and return different.
Yeah, I cannot have string here and string buffer here. Okay. We saw a class called string buffer, which is actually a mutable string. So I cannot have two string in the same class. I cannot have two string with a string and a two string with a string buffer because it doesn't know which method to call. When it tries to figure out which method to call, it looks only at the parameter types and the name. And the reason why it doesn't look at the return type is because it's too difficult.
But if they have different parameters,
then there's no problem. If they have different parameters, no problem. Okay?
Would it matter at all if the two, if like string history and looking at one had a common ancestor?
So if they both had a common super, which is object,
Yeah.
okay? If there was if object had two string, and if you could subclass to string, which you can't, okay, then you could go and say specialized string here in a subclass in a subtype, okay, and that would be allowed because then things don't go wrong. Because one is a subclass of the other, we know that this one is the most specialized case of the other one. Okay, I'm getting ahead of you guys, and I'm not going to ask you on the exam at this point, because I haven't got slides on this. But since you asked the question, yes, you can. As long as one type is special case of the other type, and one type appears in the subtype, and it's just complicated to do, but it will change. It does change. Okay, I'll try to come up. I'll try to, in some context, I'll try to show you that rule later. Okay. And what do you think? Should an interface be able to extend another interface? Should it be able to extend an interface that is extended by it? Okay. Should interface A extend an interface that extends the first interface? Should you have cycles? And that just makes logically no sense, right? This is both a specialized case and a regular case. So cycles will not be allowed, though DAG is allowed. Okay, and it just conceptually doesn't make a sense. You can't have a general case both be a special case and a general case of some other thing. Okay, and for your next assignment, you need to understand this multiple inheritance. And I'll come back to an example that confused us a little bit because it left us a little wanting. I had this example of a BMI spreadsheet and calculator that implemented multiple interfaces. And you in your token classes do implement multiple interfaces, so this is not something new. And we had some methods that were being implemented from one interface, and some methods that were being implemented by another interface. We've seen that concept before. Okay? So this was a way of having this class be both this and this. Okay? So the idea was that you can behave both as a BMI spreadsheet and as a BMI calculator. Okay? It doesn't matter what these methods are at this point. Just the fact that there are two sets of methods. Okay, so then when we went and tried to type BMI spreadsheet, we could type BMI spreadsheet the variable either using one interface or another interface. Okay, if we were going to type using interfaces. And if we typed it using BMI spreadsheet, then we could go and call the methods in BMI spreadsheet, but we could not go and call the methods in BMI calculator. Okay, so I commented this line out because if I try to put this line into Java, Java will say, sorry, calculate BMI is not in BMI spreadsheet, the interface. Okay, and there was a question at that point, what do we do? I mean, we want to use both sets of methods. You don't let us use classes as types. Okay, if I use the BMI spreadsheet and calculator as a type, there will be no such issue. So I'm not letting you use classes as types, and I'm not letting you get the full functionality of that class. Okay? And with our newfound knowledge, what could we do to solve this problem? Extend both interfaces. Okay? I could have BMI spreadsheet and calculator, extend both BMI spreadsheet and calculator, and then I could go, and that's fine. An interface can extend multiple interfaces. We just saw that. A class cannot extend multiple classes in Java. And it's all right for an extended interface to not add more methods. Okay, this was the question that was posed last time. I said that's okay. We're just doing some classification here. And we may later have methods. Yeah.
How come like a class cannot extend multiple classes, but you can extend multiple interfaces?
We just saw that, right? An interface can extend two interfaces because the two-string method, when you add two string methods together, they're the same two-string method.
Right. Okay.
Just the headers. Okay? So, and I can now type a BMI spreadsheet and calculator using this extending interface. Okay? And now I can solve my problem. Rather than saying typing BMI spreadsheet as a BMI spreadsheet, I go and type it as a BMI spreadsheet and calculator, and now both of my methods can be accessed. Okay? Questions? Okay, so this is something you need to do. Once you understand this, it's trivial to do it. And this is something you have to do with your token classes now. That your token classes are currently implementing multiple interfaces. Have them in each class will now implement a single interface. Different classes might implement different interfaces, that's all right. But these interfaces will be extending the original multiple interfaces. Question? And you know, now I'm going to change my rules a little bit now that we have this newfound knowledge. Every public method of a class must be in an interface. Yes, that's what the rules you use so far. And a class should implement a single interface. Okay, that's just going to, you'll find that that's just a good idea because you don't end up doing casting. You can always circumvent the problem I showed you by doing casting. Casting is just ugly, it's dangerous, you don't want to do it unless you really have to. And so from now onwards, you know, your class should implement a single interface, but that interface could extend multiple interfaces. Okay, questions? Okay. So let's talk of constants. We can inherit method headers from interfaces, but we can also inherit constants from method interfaces. Constants can occur in also classes. So can you see some confusion that can occur from this example? I have a string history that has an array whose size is max size. Okay, we saw that we declared a constant in the string history. I have a string database that extends the string history and implements string database, the interface. And if I leave the picture as like this max size refers to the max size in a string history. And now can I try to confuse Java? So if my superclass also defined max size, I would get the most specialized max size, right? That's not an issue. Where else can I define max size? In the super type of a string database is a string history. A string database is a string history. A string database is also a string database. I could do this. I could have string database extend string history. Of course, I do that. And define the constant in string database. And now this value is different from this value. It's not as if I'm just inheriting a name. I'm inheriting an actual value. And the question is, this print line refers to this max size in its superclass or this max size in its interface. I'm sorry. I confused you. This is interface. I just did some PowerPoint editing this morning. Public interface string database extends string history. Thank you. Okay, so reread this as interface. Now, What should Java do? What are its choices? It could choose the class. It could choose one of the interfaces. There are multiple interfaces. Or it could just say ambiguous. What do you want? You don't want to be a language designer. Okay? It's tough. So this is going to be, it's just going to say it's ambiguous. Okay? So even though, Java thinks we didn't quite get rid of the multiple inheritance problem because we allowed multiple inheritance among interfaces and because we allow interfaces to define constants, actual values. So we kind of got rid of the problem, but not quite. Okay? So I told you inheritance is going to make your head hurt. Okay? And it does, right? And the thing is, it's a very powerful thing, and I just can't not address these things because you're going to face them. You're going to do this. You're going to define constants sometimes here or there. So we have to know the answers. Okay, any questions? It'll all sink in as you start programming. It'll sink in better. Okay, and supposing I got rid of the print line statement in string database. So I'm no longer accessing the constant in string database directly. And now if I go and type string database, the variable, as string database, okay, and this is a public constant. Okay, so again, this class should be replaced by an interface. I say print line string database dot max size. Can you guys see that is it the same situation or different? So I'm not putting print line in the string database class, which is what I did. I print line the inherited value. I'm in an external class, in the main class. I declare string database to be of type the interface, and I say string database dot max size, which you can do, by the way. You can go and take an instance and say instance dot static instance dot variable, public variable. Okay. Can you guys see that maybe the answer is a little clearer now? So at the point at which, what does Java know at this point? That string database, the variable is of type. It doesn't know what class is going to be assigned to it. So this max size would refer to the interface. Okay, that's just fine. But, so interface constantly. But if you were to type it using a class, then the same ambiguity we had before arises. Okay? Because the class inherits from one class and it implements another thing, so it goes and says this. Okay? So, a lot of tricky issues with inheritance. Okay? And now you can see why Gosling went the way he did. Because with multiple inheritance of constants, things are getting a little confusing. And so he tried to reduce confusion, but we did need interface extension. So there was a compromise between flexibility and ease of understanding. Okay? So this is not allowed. Okay, and the nice thing is that your compiler will go and tell you, which is true, which is, it'll catch you with these errors. Okay, just to wrap up multiple inheritance a little bit. We are not wrapping up inheritance. There was a question in Piazza once, that what happens with annotations? Are annotations inherited? Okay, and so you see here that there's an annotation structure pattern, point pattern for mutable point, the interface, and I've got something, and the same annotation can be put also with a class. And then if I have a mutable point that extends a Cartesian point, this should be mutable point here. So a mutable point extends a Cartesian point, implements mutable point, the interface. We have a confusion. Okay, so in Java, annotations are not inheritable. But in practice, you do want some inheritance. You don't want to repeat things. So object editor goes and simulates inheritance. And what it will do in this case, even though I did the simulation, I don't remember, I don't know, because I don't know how to reason about these things. It does one of these two things. But it's ambiguous. But if you really want to be sure about what happens, please go and put that pattern with the most specific type, and then the most specific one will be used. So the class of the object that you're displaying, it will get precedence over its supertypes. Okay. And so again, somebody asked in Piazza, and I said, I really don't know, because I don't remember, because for different annotations, I did different things. And to show you why that might be the case, and to show you a more general concept in inheritance, so Java does not define inheritable annotations. So this is object editor simulating inheritance using its own rules. Okay. So, we've said that when we have multiple inheritance, we have to either disallow it or choose make one of the many choices. Okay. Can you imagine making multiple choices? Saying, yeah, I'll choose you and I'll choose you. Some languages did do that. And let me give you an example here. So with point, I can associate an explanation annotation. Again, if you guys remember, I never required you to do this, but your tooltip text will show you the explanation value. Okay. So again, I did this morning all these editing, so this should really be, I think, mutable point. Let's go and see whether this will work. No, actually, this does work. Then I've said with Cartesian point, another explanation. Okay, so my interface has an explanation, my class has an explanation, and my subclass has an explanation. So in the case of subclass, it becomes ambiguous. Do I use a Cartesian point? Should I use point? But can you imagine doing all of the above? So there are some languages that say, if I inherit 5 methods, I will call all 5 of them in some order. And in this case, what I do is I just concatenate all the explanations into one long string. Okay? And so I say, uses Cartesian representation, location is in Java coordinate system, and has max and min values. Okay? So you get some combined string for the whole thing. Okay? So this is just an example to show that multiple inheritance can go another way too, and try to make multiple choices at the same time. But this is really getting dangerous. You don't want this as a general rule. Maybe for explanation you can do this. And that is why, like I said, I did different things with different annotations. So there's no uniform rule, and I can't remember them also. Okay? So multiple inheritance is confusing. That is sort of the main point of this lecture. Okay? Okay. So sometimes inherited attributes can be combined rather than overridden. Inherited and calling super. And the reason why some languages, said that you shouldn't, what I'm trying to say is that many times in an overridden method, you call super. So if you had multiple inheritance, you could call multiple supers. This super or that super, there's a way to name that. And that's effectively doing multiple methods at the same time. So this kind of multiple inheritance has been proposed, but in Java it doesn't exist. Okay? So when you curse Java and say, why doesn't it have multiple inheritance? Now you know the kind of confusions it can cause. Okay. Let's just address a question that always arises, which is how to get inheritance right. Okay? We've got this power. We've got only single inheritance. That's good. Our flexible in case of classes. So that reduces our flexibility. So that puts more constraints. So that maybe helps us get the answer quicker to this question. But let's for your next assignment, you'll have to worry about this issue, because when you in your next assignment, meaning the one I'll write on Thursday, for your assignment number 6, I've told you to only put inheritance in tokens, because the answer is somewhat straightforward. Putting inheritance in shapes the answer is much more complicated. I didn't want you to go in the wrong direction. Some of you already used inheritance, and you might have to redo some of these things. But there's good and wrong. There's right and wrong about inheritance. And I have just 5 minutes left, but let's try to go and broach this issue, because it's a very important issue. And you might want to start with the shapes classes. Okay? So one rule could be, if T1 contains a superset of the method headers in type T2, then make T1 extend T2. Okay? So again, there's a typo here. So if some type T1 in your head, logically, has a superset of the methods of some other type T2, then physically make T1 an extension of T2. Okay, that's one rule. Okay, and so by that rule, when I'm following the rule here because the size method is something I want in string database, and I don't want to replicate that size method in the string database, the interface. So I go and extend string history. I want the size method implementation in a string database, so I go and extend it. Okay, and I'm not following the rule here because I have the size method duplicated both in the interface and in two different interfaces. And basically all of these methods are being replicated in this interface. All of these methods are being replicated in this class. Okay? So you can imagine that as the TAs want to go and do this grading to see whether you actually use inheritance correctly, they could go through every type, figure out what methods are implemented in that type, see for each method header how many types implemented, and based on that can go and figure out if one type has a subset of the methods of another type and say, hey, that other type should be extending this type. They can write a script to do this. Okay? And if they wrote such a script, would that be a good script? So again, the question is, when do we know we got inheritance right? I have to give you assignments where you exercise inheritance. I'm not going to be able to look at the user interface and say, oh, you use inheritance. The whole idea of inheritance is you can do the same thing in a better way. So we have to go through your program. We can go through your program and use some rules in our head, and every TA can use different rules. Okay, and so you may get points deducted, you may not. Or we can write a program that says, looks at all the types, figures out what types of methods, what are the methods you've implemented, and says, oh, you've got a superset of the methods here, and you should be extending. So if I was to write such a program, how could you confuse it, or how could you prove to me that that program is perhaps not the best program to write? You don't want to use inheritance, but you don't want to get points deducted, so what could you do?
You can just extend something that you didn't call the interface. So I'm only partially using this, so it's why it's
So the rule is that this is a set, right? Let's look at these two examples. This is a set. This is a superset. I have not extended. I can go to every class and find its interface methods. Every interface and find all its methods. I say these methods are the superset of this, but I don't see an extension link between here. So I take out 1 point for each method or 2 points for each method you could have used. I write this script and you say, you know what, I don't want to use extends, but I'll defeat your program. And maybe your rule is not correct. Yeah? Too late in the hour? Let's quickly, I could go, so there's multiple header duplication. Okay, we see that here. There's multiple implementation duplication. This is the kind of issue that I want to go and detect in your programs if I'm going to see whether you have used inheritance correctly or not. Okay? And I could go and say, okay, I'm just going to call this size database, element at database, size database, element at database. I've defeated your program. Right? And by the way, is this good naming? I mean, I am in database class, but do I need to go and say size database? The fact that this object is of type database means it is a database, so we already know that. So we shouldn't be, I mean, this is not good naming. So basically, you will get the points for, maybe we won't detect the inheritance issue, but maybe we will go and, detect some other problem. And the problem is that the same conceptual operation, and that now we get into some subjectivity, has been replicated, okay? And we don't want the same conceptual operation to be replicated. We want that to be inherited, okay? So the rule is a little bit more, that's why inheritance, I keep telling you, is a difficult concept to use. It's a great tool, but it requires some practice, and you should not be naming this a size database. And if you don't name it a size database, our program will actually be able to find that. Okay? So same, okay, so sorry, I lost the recording there. I could go and extend this class this way. And my program will say, good. Okay? You've reused the methods. And yet I'm going to tell the TAs, please find these examples and say they've overused inheritance. Why? What is the problem with this? Yeah.
The X and Y are really, what you can't use a line as a line is not equal.
So last time you were the one who said that T1 is a T2 if you can substitute T2 with T1. And a line is not a point. We know in our head, logically. Okay? And T1 is a T2 if it can be substituted. So please, please, please don't do this. And if you don't do this, what should you be doing? We'll wait for Thursday. Okay? Okay? Oh, sorry, I lost the recording there. I could go and extend this class this way. And my program will say, good. Okay? You've reused the methods. And yet I'm going to tell the TAs, please find these examples and say they've overused inheritance. Why? What is the problem with this? Yeah.
The X and Y are really, what you can't use a line as a line is not equal.
So last time you were the one who said that T1 is a T2 if you can substitute T2 with T1. And a line is not a point. We know in our head, logically. Okay? And T1 is a T2 if it can be substituted. So please, please, please don't do this. And if you don't do this, what should you be doing? We'll wait for Thursday. Okay?